Hello everyone, today we are going to be going over some Blind 75 Leetcode today in C++, and today we will be going over remove nth node from end of list. And before we get started, what we need to do is we always have our 4 questions to be able to understand and solidify set concepts of and break down the problem. So we ask ourselves what the input's going to be, what data structure / algorithm / technique we need to use, what are we going to do with the data, and what our output's going to be. So to give a breakdown of the problem, given head of a linked list, remove nth node from the end of the list and return its head. Okay, so this problem is pretty tricky for the most part because, one, we are given the explicit instruction of the end of the list. So initially, I made this mistake myself a bunch. I thought, oh yeah, linked lists can be treated like an arrays because they start at 0. But no, that's not the case. We have to start from the end of the list, and then we have n representing the node of the linked list, what we're doing. So we're counting from the end of the linked list. So we have 1, 2, and we're going to remove this second node from the linked list since we're counting directly from the end altogether. And then we will be finally returning the head of said node at the same time. So it is kind of tricky, so make sure that you actually read through the rest of the problem to understand the full context of what we're looking for versus just blindly jumping in. That's my biggest mistake of what I did, because I thought, oh yeah, like lists, I can treat them like an arrays, but no, that's not the case right over here. Okay, so I'll break down what we are given. So we are given a linked list and an integer n, which represents the node we are removing. Yeah, okay, here we go. And what data structure / algorithm technique we're going to use. But before that, I'm going to ask what the output's going to be. The output will be a modified version of our linked list. And our data structure that we are going to use, we will use the 2-pointer approach, because we don't know where specifically n is going to be located to start. However, what we will be doing is that we are going to have our first pointer and second pointer point directly at the head, and then we're going to move our pointers up the list until we have found n, and then ultimately remove n, and then output our final linked list that has the following. So for our steps, what we are going to do, we are going to first initialize our 2 pointers at the head of the list, where the head is typically the start, and then we're going to move the first pointer n nodes ahead. Then if the first pointer is null, like there's nothing there, we return the next node of the head, and this means n is equal to the length of the list, and we need to remove the head node. So that means, like, for example, if we have this to start, we're counting backwards to begin with. So that means that n will be 1, 2, 3, 4, 5. So it will be this case, for example, where we have our n being equal to the element of the 5th element, which is right here, which is our head, right over here. All right. So then we would then move both pointers until the first pointer reaches the end. And then what we will be doing is then make the next of the second pointer when n is removed to the next of the second pointer, which efficiently removes the nth node from the end. Kind of repetitive, but we got this. And finally, we're going to return, as stated in the problem, we need to return the head of modified linked list. use a for loop to iterate through. Okay, make sure we keep that. So now we're going to just keep going. So our first point is that we are going to create two nodes that represent our head. First is equal to head, and then list node. Second, make sure we put our semicolons at the end, as usual. Both of them will be pointing to the head, which is the beginning of the list. All right, and then what we'll be doing for our for loop, int I is equal to 0. I is going to be less than, since n represents the element we need to remove, or node we need to remove in our linked list. I is going to be less than n until we hit it. We're going to increment I until we get to where n is located. And then first is going to be equal first to next. So that way we can just move our pointer directly to where n is going to be, while it's incrementing all the way up to n. And then, in the case, if first is equal to null, as in where we're at, we will return the head, which will then be next altogether, indicating our third step. And then we will move step 4. We're moving both pointers until the first pointer reaches the end. Well, first is next. No. First is equal to first. Next. Second equals second. Next. And finally, what we're going to do with the data, we're going to do step 5, where we make the next of the second pointer to the next of the second pointer, so that way we can have our entire modified linked list. Okay, second, next, next, and finally we're going to return the head. So step 6. So make sure I get this right. Let's modify. Alright, passes all the test cases. Now let's just clean this up so that way you folks can be able to take a good look at the whole solution. Here we go. Make sure it's all cleaned. Submit the problem. And here we go. Alright, so now just to give a rundown on everything else. In terms of the time and space complexity, the time complexity is going to be very unique to start with. Instead, it's going to be O of L, where L is representing the number of nodes in the list. And this is technically in the context of constant time, except for instead of having, like, for instance, elements of an array, we have the length of the linked list. So the longer the linked list, the longer the time it's going to take for the solution to be able to run, and it's technically in constant time. And then, however, given the fact we're just scanning through the entire linked list, it's going to be linear, since we are using only 2 pointers to be able to just scan throughout the rest of our entire linked list. So yeah, this was remove nth node from end of list. And yeah, if you have any questions of any kind, feel free to put them in the comment section. And if you enjoyed this video, feel free to like and subscribe. And have any more requests, again, feel free to comment below. And as always, take care. Cheers. Bye-bye.